Cirrus Migrate Cloud is a patented solution created to help customers move data between clouds with the least impact on production operations. It is block storage array agnostic, giving customers a single tool for all their block data migration requirements. Cirrus Migrate Cloud enables migration from on-premises, cloud to cloud, or even within tiers in a cloud. This short video will demonstrate Cirrus Migrate Cloud migrating data from an on-premise DM5 fiber channel disk to an SSD drive in a VM in Google Cloud Platform GCP. The Cirrus Migrate Cloud agent is already installed with the project-specific curl line that can be copied from the Deploy Cirrus Migrate Cloud section here. Since there's no destination volume yet, we'll use console.cloud.google to add a new SSD disk type to the GCP VM. We can also attach an existing disk to a GCP VM. So now the newly created destination disk is discovered in GCP and is paired with the source fiber channel disk dev DM4. Now we'll connect the two hosts by clicking the H2H Connection tab in the Cirrus Migrate Cloud web console. Once connected, either side can send data to the other. We'll use the on-premises host agent as the source and the Google GCP VM host agent as the connection destination. We'll select the device to be migrated to Google GCP, which in this case is DM4. We will migrate the source 1 GB fiber channel disk DM4 from on-premises to SSD disk type to the GCP VM. Now we're going to create the migration session and start the migration. The first step is to select the migration parameters. IQOS is Cirrus Data's intelligent quality of service. It automatically throttles back the migration when the source volume becomes more active and opens it up when the source volume is less active. Now we'll select the appropriate IQOS level for this migration. We can choose from minimum impact to relentless. For this migration, we'll pick aggressive. Here's the dashboard to let you know how the migration is going. So now the newly created destination managed disk is discovered automatically in GCP and is automatically paired with the source fiber channel disk dev DM4. We can observe the parameters of the session, migration progress, and host details. We can see session volumes, source, destination, changes, migration rate, and the remaining data to synchronize. This example IQOS graph from an application workload with more substantial production I/O shows how the migration I/O is reduced when production I/O increases. We know an application is running that's appending records to the database. To see the dirty or change blocks during the migration process, we can click on the View Change Data Map icon. Observe that the dirty blocks are being tracked and shown here as blue dots as we add database records. Next, we move to finalize the migration. The first step is to trigger cMotion. cMotion is used to swing the workload over from the original on-premises fiber channel source disk to the new destination VM disk in Google GCP. For the case of remote migration, where there's a new host VM at the cloud that is pre-configured to run the migrated workload, cMotion effectively eliminates the final synchronization. For the final cutover, cMotion is triggered. Then open Session Actions and select Final Cutover. Note that this step is immediate and there is no final sync because cMotion already ensured that all the updates were redirected to the destination. Once the final cutover has completed, mount the destination volume to /data of the destination GCP Linux VM. Execute ls-l/data at the destination to confirm that the file sizes and attributes are identical to the same command performed on the source on-premises fiber channel host. This patented solution is key for everyone moving to Google GCP from any on-premises fiber channel disk source.